Hello everybody, welcome to today's lesson. Today we are looking at identifying the slope of a straight line. So when we talk about the word slope, we are going to be referring to slope as what we call the gradient of a straight line, okay? So basically how steep that straight line is. So by the end of this lesson, we will be able to identify a positive and negative gradient from a graph. And also if I give you two coordinates or if I give you a graph itself, to be able to write an equation for that line, okay, by identifying what the gradient would be. So in terms of a slope, we know a slope is at an angle. We, in this case, refer to slope as being the gradient, which is a measure of how steep a graph is. Okay, so if I have a set of axes, which I have highlighted in blue, we have our x-axis and our y-axis. If my line is pointing, if I draw an arrow at the top to the positive x direction, okay, we say that that has a positive gradient. So this m value for gradient is going to be positive. Whereas if I have over here, again, my set of axes are in blue, my black line, and I draw an arrow at the top of it and it is pointing in the negative x direction, we say that it has a negative gradient, okay, which means my m value is going to be negative. So we know the equation of a straight line is always going to be y equals mx plus c. Okay, so y equals mx plus c, where this m value, we are now learning it is the steepness of the graph, so what we call the gradient. And we knew from last week that our c value is our y-intercept. So where on our axes the line hits that y-intercept. All right, so in terms of looking at these two, okay, the way that it's shown is if I have an equation, y equals 3x plus 2, that 3 is positive, that number is positive, which straight away I know my graph has to be like this, or like this, or like this, or like this, okay? It's facing the positive direction. Whereas over here, okay, I have y equals negative 2x. So my gradient is negative, which means my line is going to be facing this way, okay? Going anywhere in this negative direction. So in terms of calculating our gradient, basically we need two coordinates, okay? So our gradient or our slope is looking at how much we are rising between the 2 points, okay, so the vertical distance between the 2 points, and then how much we are running, what we call the horizontal distance. So run is the horizontal distance between our two coordinates. So if I were to have two coordinates, say this coordinate and this coordinate on a graph, okay, my rise is how much I have to go up before I'm at a same level, and my run is how much I have to move across to get to the other point. Okay, so an equation that we use to define rise over run is basically this equation here. Slope equals y2 take away y1 over x2 take away x1, where y2 and x2 basically belong to your second coordinate and y1, x1 basically belong to your first coordinate. So for any coordinate, we know that we always write the x value first and the y value second. And if I have another coordinate, again, it's always going to be written x and y. So for my first coordinate, I make it x1, y1, and for my second coordinate, I make it x2, y2. Okay, and we'll go through an example in a moment. But basically, in terms of looking at gradients or slopes, it's basically measuring the rate of change of y as x changes. So as x increases by 1, what's happening to my y value? So a slope of 5, okay, a gradient of 5 basically means that for every increase in 1 of an x value, so for every x value that I increase by 1, how many y values am I increasing? So if I'm increasing x by 1, okay, and then increase by 5 means I'm going to have a positive gradient, because if I were to join those two lines together, the angle I'm making is going towards the positive direction, whereas the slope of negative 5 basically means for every increase in one value of x, so again, for one value increase, there is a decrease of 5. Okay, so decrease means going down, and if I show my two coordinates, the angle of my slope is pointed in that negative direction, so it's a negative gradient. Okay, so positive slope always going this direction, negative slope always going this direction. What we have a zero gradient. Zero gradients are basically for any horizontal line. Okay, so for any graph, okay, if I have my set of axes, if my graph is cutting the y-axis at any point, we say that that's a gradient of 0. Whereas in this instance, if we're going the opposite direction, okay, so vertical lines, okay, we say that they have a gradient of 0. A gradient that's not defined. Okay, so in this instance, for a horizontal line, my m equals 0. For this one, we say m is undefined. Okay, and we'll get to parallel lines at the end, but parallel lines are basically two lines that run right next to each other, okay? They have the same slope. They're like train tracks. They're never going to intersect with one another. We say that they have the same gradient. All right, so again, just to show you in a diagram that is not mine, that gradient is rise over run. So if my rise and run are both positive values, then it's going to be a positive gradient. Whereas if my run and rise, one of them is negative, my gradient will also be negative. All right, so now to look at an example. So basically, I've been given a graph and I have to identify what the slope is going to be, what my m value is going to be. So we know that our formula is m equals y2 take away y1 over x2 take away x1. That's always going to be our formula. So we need to identify two coordinates on our graph. Okay, so here I have got this coordinate here, which is 0, 2, and this coordinate here, which is 4, 6. So I've labeled it looking at my first coordinate, x1, y1, and then looking at my second coordinate, x2, y2, because x is our first value, y is our second value for a coordinate. So I'm basically substituting those values in. So y2 we said is 6, take away y1 we said is 2, over x2 which we said is 4, take away x1 which we said is 0, and then we solve that. So 6 take away 2 is 4. 4 take away 0 is also 4. 4 divided by 4 is 1, which means my gradient is 1. I could also find the equation of this straight line if I wanted to, now that I've got the gradient. So we know that an equation of a straight line is y equals mx plus c. Okay, so where y equals m is my gradient value, so it's going to be 1x plus c. Remember our c is our y-intercept, so that's going to be a value of 2. So I'm going to go plus 2. In algebra, we don't have to write the 1 in front of the letter, so that will just be y equals x plus 2 would be my equation. Okay. So now though, we are looking at finding the gradient. So if you can do m equals 1, you can more steps over and figure out the equation, even better, but we'll get to that point. Alright, remembering though, in terms of coordinates, I know that I labelled this one x1, y1, and this one x2, y2, but if I did it the opposite, know, like I said, an equation of a straight line is y plus c. So c is always going to be our y-intercept. M, the number that's in front of the x, is always going to be our gradient. So if we look at this equation here, I've been given this coordinate, which is 0, 3, and I can find an equation on my graph. This dot that they've circled for me kind of sits at the 1 3/4 mark, yeah, so 1.5 mark, so it's a little bit hard to tell. Let's do one that sits directly in the middle of a grid. So if this is -1 and this number over here is 1, -1 would sit about here, and I can gradient based on those two coordinates. So I'm going to say that this is x1, y1, okay, because it's my first coordinate. This is x2, y2, because it's my second coordinate. And I'm going to use the formula that we were using before. So definitely not y equals, m equals y2 take away y1 over x2 take away x1. So y2 we said is -1, take away y1, which is -3, over x2, which is 1, take away x1, which is 0. Negative and negative becomes positive. So negative 1 plus 3 is going to be a 2. 1 take away 0 is 1. So that is a gradient of 2. Okay, so my m value is going to equal 2. My c value is my y-intercept. So if I look here, that green line intercepts the y-axis, okay, at a point -3, which means my c value is -3. And I can now insert that into my equation. Y equals mx, so 2x plus c. So c is -3, so I'm going to say take away 3. That is the equation of my straight line. Some textbooks might have it in a different format where they put the y-intercepts first. That's okay, we can just rearrange it. Y equals -3 plus 2x, okay, would be the same. So any value in front of the x is my gradient. All right, on to looking at how we do this on a calculator. Okay, so we could be asked to find the equation of a straight line that goes through the point 3, 2, and 5, 10. Okay, you can do the same thing as we did before where we plot the 2 points, or we can find the gradient first. But on your CAS, since we've got it, we have our steps. So step 1, okay, is to open a new document and select add list and spreadsheets. We're going to name the list X and Y and enter our values. So 3, 2 would go here, 3, 2, okay, under our X and Y. And then our second coordinate, 5, 10, would go 5 and 10, okay, making sure that your X values are under each other and your Y values are under each other. We then click add data and statistics, okay, click on the bottom axis label box and select X. We then click on the side axis labeled box and select Y, and then follow these steps here. So press menu, step 4 analyze, step 6 regression, step 2 show linear equation, and then click enter. I want you to try this using your calculator and see if you get y equals -10 plus 4x. Okay, so it's graphed the line for you between those two coordinates and given you the equation. All right, last little bit is parallel lines. So like we said, parallel lines are basically the same distance apart and therefore will never intersect our set of train tracks. For this reason, we basically say that any parallel line, okay, lines that are parallel to each other, are going to have the same gradient. Okay, so that m value is going to be the exact same. So an example over here, if I look at this over here, my green, my red, and my blue line all have a gradient of 3, 3, and 3, which means these are parallel. Okay, so if I look at my red and purple line here, my red line has a gradient of 3, whereas my purple line has a gradient of 4, so they are not parallel. Okay, so the way you can identify if they're parallel or not is if they're parallel, they're going to have the same gradient, where the gradient is the number in front of the x. Okay. All right, so looking at our final example for the line, find the y-intercept and slope, and hence find the equation. So I have been given a set of axes, okay, so that's my y-axis, that's my x-axis, and I've been given a bold black line to find the equation of. So I have this coordinate here, which intersects at my y-axis, so straight away I can tell that that would be 0, -1. And now I have to find another point on this line. I could use this point here. That's halfway between 0 and 1. But we don't like working with fractions, so let's see if there's a whole number point. Oh, of course there is. Over here we have 1, 1. Okay, so I'm now going to label this x1, y1, x2, y2, and find the equation of that line. So my gradient, again, following the same steps. y2 take y1. Over x2 take x1, y2 is 1, take away y1, which is -1. Okay, so I'm going to write it as is. x2, which is 1, take away x1, which is 0. I'm going to be left with 1 plus 1, which is 2, over 1 take away 0, which is 1, equals 2. So my gradient is 2. We need to state whether that line is parallel to this equation here. So if you don't feel comfortable rearranging this, remember you can always use your solve function. Solve y take away 2x equals 10, comma, we want to solve it for y, so it has it in the form y equals, or we can rearrange it. So y is going to be 10. If we're take awaying 2x, we want to get rid of it, so we have to add 2x to both sides, so we're going to end up with 10 plus 2x. Now, the gradient is the value in front of the x, which is 2, and we also got a gradient of 2 for that equation, which means those two lines are parallel. So yes, they are indeed parallel. All right, so following the steps to figure out the gradient and then seeing if they are the same or not. So this is just typed up for you, okay, so you can go through that on your own. And again, I've got the calculator steps at the bottom. If you have any questions, please leave them in the comments below. Otherwise, I will set your questions. Thank you.